Hi everyone, we're going to find the radius of convergence and interval of convergence of the series. Alright, first we're going to find the radius of convergence using the ratio test. So we're going to take, this is your a sub n right here, and we're going to use the ratio test as the limit as n approaches infinity of a sub n plus 1 divided by a sub n. Now, for this to be convergent, it has to be less than 1. So this is going to equal the limit as n approaches infinity. And we take our a sub n, so there's n. So we're going to put n plus 1. Square it. Then you have x to the power of n plus 1. Divide it by 2 to the power of n plus 1. And now we're going to divide by a sub n, which is the same as multiplying by the reciprocal. So multiplying by the reciprocal, we get 2 to the power of n divided by n squared x to the power of n. Now let's simplify this. We're going to get the limit as n approaches infinity. Now, looking at all of this, let's look at the x. When you look at the x's there, you're just going to get x using your powers of exponents. And then we still have this n plus 1 squared. Also, looking at this one using your powers of exponents, that's going to be 2, because you have 2 to the nth, and you minus n plus, it'll be minus 1. I didn't write that very well. So it's n, when you use your laws of exponents, that's n, and then you subtract the n plus 1 using your quotient properties. So that's going to give you 2, and we still have the n squared. All right. Now what we can do is factor out this x2, x divided by 2. So that's going to be absolute value of x divided by 2 times the limit as n approaches infinity. And I'm going to take these pieces and divide by n. So this is going to end up being 1 plus 1 divided by n, and then you square it like that. All right, so as we evaluate the limit, this is just going to go to 1 squared, and we're left with absolute value of x divided by 2 times 1 squared. This can be written as 1/2 times absolute value of x. Now, by the ratio test, the series converges when this is less than 1. So if I cross multiply here, that would mean that my absolute value of x has to be less than 2. I'm just multiplying through by 2. So the radius of convergence is r equals 2. Now we're going to find the interval of convergence by using this formula here. I'll show you. So for the interval of convergence, which matches up to case 3 of our radius of convergence, we're going to do this part. So we're going to let x, let's just look at x equals plus or minus 2. Both series, and I'll write this as n equals 1 to infinity, and then we have negative 1 to the nth power times n squared x to the nth power divided by 2 to the power of n. Basically, this can be written as, for our x, that would be plus minus 2 to the nth. All right, so this is going to end up being the sum is n equals 1 to infinity. And for this, we're going to get minus plus 1 to the nth power n squared. So this is the both of these series for the plus and for the minus here, diverge by the test for divergence. Okay, because the limit does not equal 0. So since both of them go off the limits as n approaches infinity of absolute value of negative plus 1 to the nth power n squared, both of them equal infinity. So your interval of convergence is still your plus and minus 2, but it can't equal negative 2 and 2. So you have open intervals. If it converged on one of these endpoints, it would be a closed interval. But since they both diverge, they're open intervals. Thank you. Have a nice day. Bye-bye.